Hi, my name is Hideo Joho from University of Tsukuba. I'm introducing a new pilot task called Lifelog. This task is co-organized by Cathal Green and Rami Al-Batal from Dublin City University in Ireland, and Frank Hofgartner from University of Glasgow, UK, and myself from Japan. So you probably noticed that much of the tasks proposed introduced in this kickoff events are text-based. And NTCL has been very strong in text-oriented tasks. But here we try to introduce some new elements to this culture by bringing more image, multimedia-oriented tasks. So this is one of the Lifelog data Cathal Green took while he was visiting Tsukuba last year. And this was one photo. He was preparing a lecture, a guest lecture at Tsukuba University for the master students or undergraduate students, and I was giving him our book. So there's so much memory. Just single picture brings back so much memory from one person's particular time and a particular location. So such a powerful means has not been very well exploited in the context of information access field. So this is what we try to do in this task. I'm sure many of you have heard of the word lifelog, lifelogging. It's becoming kind of buzzword. It can be through many devices, like if you keep tracking what application you're using on your desktop and laptop, that becomes your lifelog tools. Many of the activity tracker, how much you walk, how much exercise you did, how long you slept. And the camera, wearable camera, is also a very popular device to capture your daily activities, and probably this is one of the examples of what kind of photos you can take. So lifelogging can generate massive amount of multimedia data in just one day, which needs to be organized and make it searchable. So this is again some of the examples: visiting some places, riding a bike in Tsukuba, doing some work at a cafe, maybe eating with your friends. So Lifelog task is to design and encourage researchers advance in organizing and making retrievable from this massive Lifelog data. And gathering those data from multiple sensors and cameras can generate a huge amount of data in a very short amount of time. So the question is, how do we, but those are all multimedia data, so they don't have much semantic data in it. So how can we overcome the semantic gap issues to access personal Lifelog data is one big challenge we are addressing in this task. And also, for a given query, typically document retrieval task, the unit of retrieval is either document, paragraph, iUnit, and so on. They are fixed. But for the Lifelog data, maybe a part of the picture might be a retrieval unit, maybe one image might be a retrieval, appropriate retrieval unit, or maybe a series of images may be an appropriate unit of retrieval. So the size of retrieval unit is highly can highly be dependent on the queries. So these are also the new issues that we're bringing in here. And also, obviously, this is image analysis people might be interested in, HCA people might be interested in, traditional textile people might be interested in. So different disciplinary fields can contribute to address these issues. So what tasks are we proposing? Well, this is the first time we are making this kind of data set available to research purposes, and maybe, if I may be bold, maybe this is the first time any major evaluation forums like TREC and CLAY and NTCIR producing community-based Lifelog data as a such task. So we start from very well-known ad hoc retrieval task on very different data set. So here we try to retrieve n set of segments. The retrieval unit can be varied, as I said earlier, but basically it's ad hoc search. We have a typical information need, and your task is to retrieve a set of images from the collection. And it can be automatic, like a traditional way, or it can be interactive, where any sort of manual intervention will occur during the process of retrieval. So this is the first subtask, and probably the main task, non-item search task on Lifelog data. And second one is not all data sets are simply retrievable. Many of the massive corpus may be best served by browsing the massive collection. So building tools that help people to explore this massive Lifelog data is also one of our subtasks. And this is not a sort of task where we have a rigid definition of evaluation measures, more like encouraging people to access the data, think about what's the best way to exploit these metadata, image data, and other set of data which I explain later to create a new type of UIs. And we're expecting those people who did that to present it at a conference with interesting demos and so on. So here's some of the UIs that the DCU people created. So this is day 1 to day 7. Probably this is Monday, and that's the weekend. This is the 6 o'clock, and this is 10 o'clock, and you can see that just a tiny thumbnail of a bunch of images can tell you how your life goes on. And this is such a simple visualization, but for example, you can see that these blue screens are maybe the skies, and it's possible that those gray things is your office wall, so that you are in the office for the whole time. Probably on the Tuesday night you had a party and you stay up quite late. So this such a simple visualization can make a strong understanding of your life patterns. So this is also a good challenge. You can make more detailed day-to-day visualization like this. This is, I'm explaining you later what sort of data. This is a lighting level. So where you are in bright places or dark places and so on. This is based on more like the people-oriented one, who you had a meeting with, in what day, and so on. So again, we don't expect people to develop such a detailed, well-designed UI from the beginning, but this is just an example of the potential that how far you can go with our data set. So what data are we providing? We are providing a number of life loggers. We're talking about probably between 5 to 15 or 10, 15 people. We ask them to put a bunch of life log sensors for 2 weeks at least, and which should create 100,000 images. And not just the images, we will get the locations, activity monitors, temperatures that comes with the sensors of the Lifelog devices, which is obviously not perfect, but it's a noisy data, but that's something you can exploit. And also, we are concerned about the privacy issues. So we do a lot of pre-processing of the data, like the removal of personal contents. We will blur the face, and so on. Also, if you are not image processing person, if you are text-based person, we do provide annotation of basic concepts, 1,000 concepts using cafe classifier on every image. So this is an example. Probably it's too small to see, but this is the image, and this cafe classifier added like the monitor, desktop, desk, screen, those annotations, text-based annotations, so you can use. This is again not perfect. For example, this picture has got a printer, and I think it says stove. Maybe that looks like a stove. So the classifier makes mistakes, and it could be the noisy data, but this is something that you can work on, and maybe decide which concept is more reliable and so on. So this is not only for the image-oriented people, this is definitely for the text-oriented people too. And as usual, we provide the basic low-level image features like histograms and so on. And the total data will be about 50 gigabyte, and you need to download those things from the DC website. So this is the rough schedule of data. I think this is a really interesting data set, and I'm looking forward to having many participation from you guys. Thanks.